Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring ratios and proportions. Before we do, let's review what a ratio is. So a ratio is simply a comparison of two quantities that can be scaled up or down by multiplication or division. So in example 1, it says the ratio of dogs to cats at a pet boarding facility is shown below. Find each of the following. In part A, they want the ratio of dogs to cats. Now the order here is important. Because they said dogs first, we will put 4 dogs to 3 cats. Or you could write the ratio as 4 to 3. But in either case, it's the dogs that had to go first, right? Now, part B, they want the ratio of cats to dogs. So this time, the number of cats goes on top. The number of dogs goes on bottom. Or you could write your ratio like this, 3:4. In part C, they want the ratio of dogs to the total. So there are 4 dogs compared to 7 total animals. I'll just put animals. So the ratio would be 4 to 7. The ratio of cats to total would be 3 cats to a total of 7. Or we could say 3:7. All right. Example 2. The ratio of dogs to cats at another pet boarding facility is shown below. Use the diagram to answer the questions. Question A. Based on the total number of dogs and cats, what is the ratio of dogs to cats? So for dogs, in our image here, we have 3, 6, 9, 12 dogs to 2, 4, 6, 8 cats. So if we're comparing the totals, our ratio would be 12 to 8. In part B, they want to list 3 other ratios of dogs to cats that are equivalent to question A based on the diagram. So we've got our first set here. That would be 3 dogs to 2 cats. That ratio is equivalent to our original ratio because all they did was divide each of the numbers by 4. Right? Now, we could also say another equivalent ratio would be 6 dogs to 4 cats. So notice that we were able to scale our ratio up by 2. That's what it means by a ratio is a comparison that can be scaled up by multiplication or down by division. All right. Now we could also use an even bigger ratio. Let's see. Here we have 9 dogs to 6 cats. So that's our original ratio scaled up by a scale factor of 3. So 3 dogs became 9 dogs, 2 cats became 6 cats. Now we can also use a ratio table to find other equivalent ratios by using scaling. So our most simplest ratio here was 3 dogs to 2 cats. Now let's say we doubled the number of cats and had 4 cats. So if we double the number of cats, we would also have to double the number of dogs. So an equivalent ratio to 3 to 2 would be 6 to 4. All right. What if we tripled the number of cats, multiplied it by 3? Well, we'd have to do the same thing to the number of dogs. 3 times 3 is 9. So 3 to 2, 6 to 4, 9 to 6, 12 to 8. Those are all equivalent ratios. All right, what if we had 12 cats Now, you can use any number you want to in this ratio table to scale up to 12. I could use the 2 and multiply by 6. I could use the 4 and multiply by 12. But I'm going to use the 6 because that's a pretty easy, we're just doubling it or multiplying it by 2. So if I multiplied that 6 by 2, I would also have to multiply the 9 by 2 to get 18 dogs, 12 cats. All right. Now, in our last box, they want to have 24 dogs. So I want you to use something in the table to determine the number of cats. Pause the video and try this one on your own. When you're done, press play to check your answer. All right, welcome back. Now, to get to 24, there's a lot of ratios I could have used, but I used the 12. And I just doubled the 12 to get 24, which means I had to also double the 8 to get a total of 16 cats. So hopefully you got that one correct. All right. Now let's use a ratio table to solve a couple of real world problems. In example 3, it says use a ratio table to solve each of the following. So it says in part A, the ratio of the number of almonds to the number of raisins in a bag of trail mix is 4:3. So in my ratio table, I've got the two things we're comparing, which are almonds to raisins. Then I'm going to put down the ratio that was given, and it was 4:3. If there are 600 almonds in the bag, how many raisins are there? So I want to put the 600, but I want to be sure to put it in the correct place. So because it's almonds, I'm going to put it on top. All right. Now what I have to do is figure out what scale factor are they using here to get from 4 to 600. If I could determine the scale factor, then I would know what to multiply the 3 by. So I'm going to do some simple division. I'm going to see how many times will 4 go into 600. 4 goes into 6 one time. Subtract and bring down. 4 goes into 20 5 times. Subtract and bring down. 4 goes into 0 0 times. So my scale factor is 150. So 3 times 150 would be 450 raisins in the trail mix. All right. Let's look at another one. Something kind of interesting happens on this one. A cafeteria has an unknown number of students in it, some of whom are left-handed. The ratio of left-handed students to right-handed students is 2:9. If there are 45 right-handed students in the cafeteria, how many total students are there? So in this problem, in this ratio table, I actually needed 3 rows because in this problem, they are interested in the total students, not just how many left-handed or right-handed students there are. So I needed an extra row. So let me put my original ratio, which was 2 left-handed for every 9 right-handed. And then if I add those together, that would be 11. All right. Now, it says, the question says, if there are 45 right-handed students, I'm going to put a 45 right there. Now, from there, we can figure out our scale factor. 9 will go into 45 5 times. So our scale factor is 5. So 2 times 5, this would have to be 10. And 11 times 5 is 55. So there are a total of 55 students in the cafeteria. Now, in previous grades, you may have also learned about something called a proportion. So a proportion shows 2 equal ratios in the form of an equation. Proportions can be solved by scaling, like we did up here where we scaled by 5 or we scaled by 150, or setting up an equation and solving. The cross products of a proportion will always be equal. In other words, if you have A over B is equal to C over D, then AD, that's this cross product, has to equal the other cross product, B times C. Okay? Now, we will use that fact here in just a minute. Okay? So in example 4, it says set up a proportion for each of the following and solve. In part A, it says a holiday decoration involves blue and white lights. So I'm going to write down the two things we're comparing. And I'm just going to use abbreviations. We're comparing the number of blue lights to the number of white lights. That's just the same thing up here as setting up a table. We were comparing almonds to raisins. Here, I'm comparing blue to white lights. Okay. Now, the ratio of blue lights to white lights is 3 to 2. So that's my first ratio. But in a proportion, I need 2 ratios. So I'm going to set it equal to another ratio. It says if there are 114 blue lights in the decoration, how many white lights are there? So that 114, you have to be sure to put it in the correct place. Because it's blue, it will go in the numerator. And we do not know the number of white lights. That's what we're trying to find. Now, remember up here when I said the cross products must be equal? So this cross product, 3 times x, must equal to this cross product, which is 2 times 114. So 3 times x is 3x, and 2 times 114 is 228. Now I just need to solve this equation. 3 times what number is 228? So to find that number, I'll just divide both sides by 3. So 3 goes into 228. 3 goes into 22 7 times. Subtract and bring down. 3 goes into 18 6 times. So this would be 76 white lights. All right. James has a jar full of pennies and nickels. The ratio of pennies to nickels is 8 to 3. If there are 48 nickels in the jar, how many pennies are there? Pause the video and try this problem on your own. When you're ready to check your answer, press play. All right, let's welcome back. I compared pennies to nickels, and it said the ratio of pennies to nickels is 8 to 3, so that was my first ratio. And then it told me there were 48 nickels, so I had to make sure to put the 48 on the bottom, and I put an X here. So if I do my cross products, 3 times X is 3X. 48 times 8, let's see what that is. That would be 4, 6, 32, and 6 is 384. Then I divided both sides by 3. So 3 goes into 384. 3 goes into 3 one time. Bring down. 3 goes into 8 2 times. 3 times 2 is 6. Subtract and bring down. 3 goes into 24 8 times. So 128 pennies. And that concludes today's lesson, ratio and proportion.